Assalamualaikum and hi. So my name is Omar Ali bin Syed Rahman. Today I will produce my mini project which is smart lawn machine. Before we start, I will introduce my teammate first. So this is my teammate. The first one is Muhammad Hazman Hafiz. The second one is Wafi Hambali. The third one Eddie Ikmal. So this is me, Sir Omar Ali, and this is my last team member, Wan Alif Aiman. So on this slide, I will explain the problem statement for our project. Firstly, manual lawn mowing can be very tiring and difficult to control, especially when used for a long period of time. This can cause physical fatigue for users. Secondly, users need to stay very close to the mower to operate it safely. This increases the risk of accidents such as injuries from moving blades or uneven ground. Next, most existing lawn mowing systems do not support wireless control. This limits user flexibility and makes the operation less convenient. Therefore, to solve this problem, a Wi-Fi based control, a Wi-Fi based control uh, system is needed. By using wireless control, users can operate the lawnmower from a safe distance, which improves both convenience and safety. This project also aims to reduce user effort, increase safety, and modernize lawn mowing by introducing a Wi-Fi control system. So, next slide. Project objective. The first objective is to develop a smart RC lawn mower that can be controlled using a smartphone. This allows users to operate the mower easily without direct physical contact. The second objective is to enable wireless control through a local Wi-Fi network. This ensures stable communication between the smartphone and the lawnmower without the need for internet access. The third objective is to apply basic microcontroller and motor driver principles. Through this project, we implement fundamental electronic concepts such as motor control, signal processing, and power management. This project aims to demonstrate the practical application of electronic in remote control systems. It shows how theoretical knowledge can be transformed into a real-world solution. This objective focuses on improving safety, convenience, and technical understanding through a smart lawn mower system.
Hi, my name is Eddie. For the system overview, this project features a remote control lawnmower that utilizes a smartphone as the primary interface. At its core, the ESP8266 functions as the central processing unit and establishes a dedicated Wi-Fi hotspot for communication. To manage physical movement, the L298N motor driver regulates the power sent to the DC motor. This setup grants the operator full maneuverability, including forward, reverse, and directional steering. What main component we use in our project? The first one is component is ESP8266 Wi-Fi module. The Wi-Fi module acts as the brain or the central microcontroller of the mower. To give our mower intelligence, we are using the ESP8266 Wi-Fi module. Unlike a standard controller, this allows for wireless connectivity, enabling us to operate the mower remotely via a smartphone or web interface. For our case, we are using our smartphone to control the mower. It processes our command and send instruction to the motors. The second and the third one is L29AN motor driver and DC motor with wheels. The function of L29AN acts as an intermediary that provides the necessary power to the motors, which drive the wheels. The L298N motor driver serves as the muscle of the system. It takes lower power signal from the ESP8266 and convert them into enough high power current to drive the DC motors. By using a 2WD or two-wheel drive configuration, the mower can perform the steering, allowing it to spin in place and navigate tight corner in the garden. For the next slide, I will talk about the supply structure of our our lawnmower. To support our entire boat is using a car robot chassis, which provide a stable platform for the cutting mechanism and electronics. We are powering the unit with high capacity 18650 battery cells. This is chosen for their high energy density and ability to provide sustained power for outdoor use. Finally, we are using jumper wire and the connector to form a kind of nervous system, ensuring the seamless communication and power flow between every hardware module.
Okay, now I will explain the project. First, the system start. When the smart lawnmower is powered on, the program begins to run. Next, the system initializes the GPIO pins and motor spool. This step sets the pin for the motor driver and prepares the motor split so the mower can move correctly. After that, the system sets up the Wi-Fi access point. This allows the user to connect a phone or laptop directly to the mower. Then, the system defines the HTTP ropes. These ropes are used to receive control commands such as forward, backward, left, and right from the user. Next, the web server starts. This web server allows communication between the user and the smart lawnmower. After the web server starts, the system handles client requests. This means the mower waits for a command from the user through the web interface. Now, the system checks whether a command is received. This is the decision point in the project. If a command is received, the mower will respond based on the command. For example, if the command is move forward, the mower will move forward. After completing the movement, the system will stop the motors to ensure safety and control. Then, the system goes back to waiting for the next command. This loop continues as long as the mower is powered on. And for the next, this is our coding that we use for our smart lawnmower.
Now for the circuit diagram part. As for the first picture, we can look that this is our wiring connecting from the ESP8266 to the LW298N and powered by the battery. Furthermore, let's go to the detailed one. Okay, as we can see here, first we connect the four wire, 2 in 1 in EN2 to the B1 and B2 at the ASP, powering the 1 DC motor represent as one of the tires, and then the other EN3 and EN4 for the B5 and B6 for the second DC motor. And we also make another parallel circuit for the switch to the another DC motor that represent as the blade of the lawnmower. And besides the EN, there is the 5 volt that connecting the switch directing to the battery, so that the control L298 powered by the battery to supply the power to all the DC motors. That's all.
Okay, for the software and IoT platform, our group decide to use Arduino IDE. It is for programming ESP8266 with our hotspot setup on ESP8266 mobile app or web interface to send control commands, and then local wireless connection. That is IoT concept. And then for the system operation, First, user connects smartphone to ASP.X260 hotspot. So the step comments from the phone are sent to the ASP.X260, and next ASP.X260 processes comments and sends signal to L298N. The fourth L298N control motor direction and speed, and the last mower move accordingly in real time. For the control logic, when the command receive, for example, forward, both motor rotate forward. If the command receive backward, both motor will rotate backward. If left, one motor stop and reverse, other move forward. And right, one motor stop or reverse, other move forward. Commands are triggered by button on the smartphone interface.
So I will talk about the testing method. First, connect phone to ASP.A260 hotspot. After we did it, we search the code of IoT in the group, and the button forward, backward, left and right is appear, and we can push the button to test the movement in all direction. We observe response time and accuracy. Check wiring and motor if have any issue or the system is not perform smoothly, and we record performance and make adjustment if needed. Have issue and solution in our project, and the common issue is Wi-Fi connection unstable, so we reconfigure ESP8260 hotspot setting. After that, the second is motor did not respond correctly. We check wiring and power supply, and the common problem is the wire is disconnect or loose, or we incorrect connect the wire. And lastly is limited power for the boost motor, so we use another method that we put a power bank to supply more power. So the final result, RC Lawnmower successful control via smartphone, smooth movement in all direction, wireless control achieved using ESP8260 hotspot, system demonstrate local IoT based control concept, photo or video we can show after this slide. So, after all this, we can make a conclusion that our project was successfully met the objective of wireless control. ASP8266 and L298N worked effectively for motor control. System improved convenience and safely compared to manual operation. Hand-on experience gained in microcontroller programming, circuit design, and wireless communication. For future improvement, we can add obstacle detection, automation, or cloud-based IoT integration. So that's all for us. Thank you.